So today I'm going to talk about setting quality targets, and before being able to talk about this, we will see that we need to prepare some other things. But let's first introduce myself. So I'm from Holland, the Netherlands, so that's in Europe. I started my career at Philips Research, also very well known in India. And I stopped working at Philips around 2000, and then I founded my own company, actually by using technology that I developed at Philips Research. So it was in the compiler construction domain. And so far I have been let's say the director of TIOBE, and I'm still am the director. TIOBE is quite known for its TIOBE Index. Probably you have heard about it. It's a top 100 of the popularity of programming languages. And I started tracking this at the beginning of our company. So here you see actually the trend of the last 20 years that I collected this data, but you see is actually not that much changed over time. So Java and C were the top languages in 2000, and they are still the top languages at the moment. But it's interesting to see what changes, and it gets a lot of traction. So a lot of people come to visit this page on our website to see what is new in the programming language world. So we have usually more than 10,000 unique visitors a day, and sometimes we have 1 million visitors in a day when we publish the new, actually the new language index. Okay, but that is not what we earn our money with in the company. So what we do is we help other companies to set up and measure code quality. We do this for more than 3,800 projects worldwide. Lots of companies are also present in India, like Bosch and Philips and Signify, ABB. Most of them are all in the embedded software domain, but our solution does not restrict itself to this. In India, we are working closely together with Meteonic. So Meteonic is our distributor in India. And together we help our customers over there to get the most value out of tools. Okay, so let's go to our topic. That is how to define realistic quality targets. But before you can do this, you actually need to take a couple of other steps. So you cannot define quality targets if you don't measure quality, or if you don't know what quality model you are using. So what I will do is I will briefly go through these 7 steps. And at step 6, we get what we wanted. But before that, we need to build up something. So the first thing is that we have to select a quality model. A quality model is something where you say, well, this is a standard that we are using to make sure that we following the quality guidelines. So let's give you an example. So here's an example of a quality model. That's the ISO 25010. So that's an official international standard that is about software product quality. And this standard defines what quality is about. There are other standards, but this one actually is the one that is used most often in industry and by most companies. So I'm very glad that we've got this standard. So it specifies 8 different quality characteristics. Some of them have to do with, let's say, things that you can see once your product is finished. So it's about reliability. Does your application crash often? Is the user interface nice to use? That's more about functional suitability. But it is also about things that you can't see from outside, but which have impact on, let's say, the internal quality of the software. So for instance, how easy is it to make a change or add a new feature, or is the code completely not understandable, so you don't know what to do? If there are many bugs in the software, it's also very hard to add to new things. And it also makes it hard for new people to get familiar with the software. So these kind of things are more internal quality related, but all of them are described in the standard. So that's very nice, and it's actually the standard quality model that is used nowadays. So I would say if you still have to choose one, take that one. So before you then can go to quality targets, you first have to do some other steps, like you have to select software metrics. So you have this standard. If you go back to this standard, it's very nice. It says, well, you should have reliable software, but what does that mean? What do we have to do to get reliable software? What do we have to, how to measure this? This is not in the standard. So you have to find something else to make sure that you can measure this. So we are actually looking for software metrics to measure your quality. But before doing so, we need to set some criteria, because not all the metrics will help. I've done some research on this recently, actually, to see what the criteria are for good software metrics. And if you look at the research, and there are 5 that are very important. The first one is that it should be objective and consistent and repeatable. What does that mean? Suppose your software metric is the number of comments coming out of a code review. Yeah, so you're doing a code review and you just count the number of comments. That is actually not objective. That's not repeatable also. Why is that? Because suppose you ask somebody in your company to do a code review, then you maybe get 5 comments. But there is also a critical person. If you asked that person, you would have had 12 comments. So it's not objective, and it's also not repeatable, because each time you get a different value. So you need to have software metrics that are objective. Another very important one is that it should be easy to compute, and if possible, you should be able to automate it, so that you can get the data without doing anything. Just press a button and you get the data you need. Well, for instance, one that is very hard to compute is, let's say, the number of releases that are out in the field. Well, yeah, how do you get this? Then you have to maybe contact all your customers and see what releases are out there in the field. So that it's not easy to compute, and certainly not can be automated. It also should be predictive. So if you have a metric, it should tell something. It should indicate, well, if this metric is low or high, that means that your software will be better or worse. That is, of course, that's an obvious one. And then we need to have support for as many languages as possible. So suppose you have a metric called the number of friend classes. So in some languages you have the notion of a friend class, but that is only limited to object-oriented languages and only for specific ones. So C++ has friend classes, but as far as I know, Java has no friend classes. So that's a metric that is only hold for one specific programming language. And the last one, of course, is that if you have a metric, then you must be able to understand it. So I don't know whether you're a bit familiar with software metrics, but there is a very famous one that's called Halstead complexity. And Halstead complexity, that's a formula with all kind of magic numbers, and I don't know what, but it's so complex. Actually, well, you put something in and something comes out and nobody understands why is that the case. So if people don't understand how it works, then they also don't understand how to improve. So it's very important that also this metric should be understandable. So, okay, that's about the metric criteria. Then we can go to selecting software metrics. And we are quite lucky. If we have the quality model, the 25010 standard, and we are going for software metrics, then about 5 years after the release of this ISO standard, the ISO committee came with a new one, the ISO 25023. And they are actually defining all kind of software metrics to measure this 25010 standard. So then maybe when I saw this, I thought, oh wait, we are done. We just have to look at these 203 software metrics, and we can go ahead and start measuring our system and define quality targets. But that's not the case. Unfortunately, these 203 software metrics, they do not meet the criteria that are set in the previous slides. So most of them are really vague. You cannot repeat them. They are not objective, etc. So actually, this one we can't hardly use. So we have to skip that one, and we have to look for metrics ourselves. So we did an extensive research of what is going on, how these quality characteristics of the ISO 25010 are measured according to literature, according to what companies are doing, etc. And then we came with a whole set of metrics. So one of them is, for instance, compiler warnings. That's obvious, of course, but also something like component balance. So is your tree structured quite well? Test coverage is one. These are things that you can measure while you already are developing software, but some of them you cannot measure yet. You first need to have a delivery of something like that. So if you look at the fourth one, average number of modified components per commit. That means that we have to commit. You have to deliver your software first before we can measure that metric. But it's a very valuable metric, for instance, to measure modularity. So if a lot of components are changed every time, the same two components are changed, then probably these components are not independent of each other. So it's a very interesting software metric. Another one is, for instance, installation time, completely different one. It's about once you have delivered your software to your customer, how long does it take before you can install it? So the installation duration. And that's something that's also objective, and you can measure that, etc. But that is only can be done after your release. And it doesn't help you with, let's say, reliability, but installability of software. It's a sub-characteristic of portability. So you are measuring something in the portability area. And there are much more, of course. But these are examples that we can use. And now we're getting close to our quality targets. For instance, suppose you have these metrics, very nice, but you are not going to do anything with it. You just have them on paper, then nothing will happen in your company. So it's very important to automate this process and make sure that you measure all these metrics automatically if possible. And for this you have to select the tools. And this is quite an extensive thingy, because there are so many tools on the market, and every tool is selling you a dream. They all say, well, we do the best job there is, etc. I made a very small selection here of, for instance, tools that measure test coverage. And well, there are hundreds of these tools doing this. So I just mentioned some of them, like Bullseye, Squish Coco. And of course, it also depends on your language. For instance, if you are doing, for instance, JavaScript, then Istanbul is a very nice tool to use. But if you are doing C#, then OpenCover is a good one. And if you do Python, coverage.py is a good one. So it depends on the language, but also on your quality constraints, but also your budget. So some of these tools cost money, some are for free. So it really depends on your budget, what kind of tools you are going to select. Well, I've added here a web page. We can have a brief look at that. So let me see. So on our website, if you go to our Tics fact sheet, there you see, for instance, all kind of languages, and if you select C++, then you see these are all the code coverage tools that we actually use for our customers. So this is already a nice set. For abstract interpretation, we're using this, for compiler warnings this, for coding standards, etc. You can see, and you can look up what are actually the state-of-the-art tools currently in the market for a certain metric. Okay, let's go back. Okay, so suppose you have selected your software metrics and you have selected your tools. Then of course we have to run these tools and make sure that they can give valuable information. But then still nothing will happen, I can tell you, in a company. So some people will have a look at it, but they need guidance. So that's why we need these targets. But before we can set targets, we have to do one more very important thing, and that is called qualification. So we have to say, suppose we have a metric, we have to tell what is good and what is bad. Because if we don't know what is good and what is bad, we can't set any targets. So qualification is really important. And it is not easy, I can tell you, because I'm in this area now for about 20 years. And it's still very hard to define a good qualification for a metric. So let me show this by giving you two examples. So let's first go to code coverage, because we looked at it before. Then of course the question is, what is a good code coverage and what is a bad code coverage? Well, the first thing that you of course see is, well, if you're talking about code coverage, is, well, we have different kinds of code coverage. We have statement coverage, we have function coverage, branch coverage, decision coverage, MCDC coverage, all kind of coverage. So where do we start? That was already a problem for us in the beginning, but we said eventually let's do it like this. We take the average of all code coverage types. And the only one we exclude is function coverage, because function coverage is about, suppose you run a test, is this function touched or not by this test? So that's a bit easy. So it's only, yeah, seeing whether a function has been called, and that's not sufficient. So we would like to look at statement coverage, what statements are actually covered, and branch coverage, etc. And we take the average of that. And then of course the question is, what is good and what is bad? And we looked at literature, we discussed it with our customers, and we came with the following. So we have defined here a formula. So we take average of all code coverage types, as I said, except for function coverage. And we take this formula as a qualification. So here at the left, you see actually the score. So if you have less than 10% code coverage, you score less than 40 in our system. But yeah, of course, you can use your own system. And we say this is equal to level F. So that's not good. It's red, so that's not good. And if you have more than 76.7%, you score more than 90% in our score system, and you have an A score. Now, this looks rather easy. There are some interesting things here. For instance, if you fill out 90 here, then you will get a 100 score. So what we say, for instance, that's part of this qualification. If you have 90% code coverage, you are so good. Don't try to get 100% code coverage, because from 90 to 100% code coverage takes so much time, and you are going to actually test really, really strange cases. And the question is whether that is really necessary. Unless, of course, you are in avionics or some very safety critical environment, then I would say please do. But otherwise, please stop at 90%. Then you are already more or less perfect. On the other hand, if you fill out 0 here, the funny thing is then you get already 32.5. Why is that? That is because what we've seen is that a lot of companies struggle with setting up unit test systems, or integration tests or system tests, and measure coverage. So this is actually to promote that if you run, and even if you have 0% test coverage, you get 32.5% in our system for free. But if you don't run it at all, you get 0%, of course. And that means that, well, you are still level F, but at least it's a kind of incentive to say, well, let's start with it because we already get some qualification. Yeah, here you see quite a complex formula. So what I was saying is it's quite hard to define a good qualification for metrics, but it's really needed. For instance, let's take another one, compiler warnings. Well, suppose you have 50 compiler warnings in your system. Then the question is it good to have 50 compiler warnings in your system, or is that bad? And it is, if you think about it a very long time, then it becomes more complex than you think. Because in the beginning you would say 50 is a lot, so that's not good. But then you think about it, well, suppose you have a system of 2 million lines of code and only 50 compiler warnings. Yeah, that's maybe okay. But if you have only, let's say, 3 lines of code and 50 compiler warnings, yeah, then you are doing a bad job. You did something remarkable, yeah, but not a good job. So size of the system appears to matter in this case. But there are other things, like suppose these 50 compiler warnings are really silly warnings that are pedantic and you can't do anything with it, and then that's less important than, of course, if there are 50 very severe warnings. So that's why we say, well, we also have to look at the severity level of these compiler warnings. And there are more things that play a role here. I'm not going to bother you with this, but then we came up with this quite complex formula to define what we call the compliance factor. So how compliant are you against the compiler warnings? You have to also take into account that different compilers have different compiler warnings, and you have to qualify them all in one system. So how are you going to do that? So that's also part of this very complex formula. Okay, what we also did for this qualification, we said, well, we have a system of ourselves, but you can, of course, use your own system and define your own system. So you can have your software metrics here. We have got these. And actually we have also a qualification for all of them. And then we have a percentage to tell you which one are more important than the others. And then if you have got this, you can come up with one indication, a qualification for your entire system. And now we are getting ready for defining quality targets, because now we have a system in place. We know how to measure it, so we have tools in place. We know what is good, what is bad, and now we can say, okay, let's play with this and make sure that these targets are met. One more thing, the system that we are using for our customers is, you can download it for free from the internet, so I've added the URL here. Please have a look at it, take from it what you want, or take the complete system, whatever. If you have any questions, let me know, then I'm happy to answer questions about how to do this. But now we come to the most interesting part, and the part that is actually what you are here for, and that is defining quality targets. So we are now ready and set to do this. And actually, if we look at it more closely, there are 2 important aspects of defining quality targets. One of them is that you can set quality targets in an absolute way, and you can also set them in a relative way. Let me give you an example of the difference. So absolute means, for instance, we don't allow any compiler warnings of level 1. That means that as soon as somebody delivers a file that contains a compiler warning of level 1, yeah, you are not meeting the quality target. You have to keep in mind that that also means, suppose you have already a very big system with lots of issues from the past, the person who's making a very small change in a file, he gets blamed for something he didn't do. Yeah, because there were maybe already 20 compiler warnings of severity level 1 in the system. And if you say, I have an absolute target, that person have to solve these 20 issues, although that person didn't introduce these compiler warnings. Well, you have also relative, and relative is almost the same, but it says you are not allowed to deliver new compiler warnings of level 1. So the difference is here the word new. And what does that mean? That means that you are comparing against something. So it could be that you compare against the previous release, or you're comparing against the start of your sprint, or against the last baseline. That's something you, of course, have to define, but that's a relative target. So there's a difference between absolute and relative targets. And we will see in some cases absolute is better, in some cases relative is better. Another important one is, what is the scope of your quality target? So that also has really impact. I can tell you by showing you an example. Suppose if you look at project scope, this one says code coverage should be at least 70% for the entire project. Okay, that means that. Now let's first go to the next one, file scope. File scope means code coverage should be more than 70% for every file. Now, what's the difference? It might seem very small, but in fact it's huge. Suppose you have changed 3 files, and that's your change set. You have edited 3 files, and you have made a very good improvement of your code. You also added some tests, so your code coverage is doing well. But for one file, it dropped a little bit. But for the other 2 files that in your change set, everything was okay. So you improved your code coverage. So the overall code coverage was okay. Well, then it's okay to deliver. But if you take file scope, then every file should have at least a 70%. So you are not, it's much stricter. So the first one is the entire project, and the second one is every file, and that has huge impact on actually the quality target and how to meet it and whether it is realistic, because probably you can tell this you can't apply this in practice to say code coverage of every file should be more than 70%. Okay, so let's take these 2 into account, and let's have a look at the 2 golden rules for quality targets. So the first one is about violation-like metrics. So what does that mean? Violation-like metric is, for instance, as we talked about, compiler warnings. Another one is, for instance, coding standards. Yeah, if you have a violation of a coding standard. But you have more, like you have also these deep flow analysis tools like Coverity and Clockwork and Bug Detective, all these kind of tools. They also come up with smells and bugs in your code. These are violation-like metrics. And actually, these are all individual, so every compiler warning is an individual warning, and getting rid of them is okay. So you can treat them one by one. And that's why we say it should be a file-based target. So you should not do that on project scope, because then people can solve some compiler warnings and in the meantime introduce some others, and that's not what you want. You don't want to have anything introduced, so it's a relative target. Yeah, so we don't want to have new ones. It's not good to say that it should be an absolute target, because an absolute target means that, well, if somebody in the past introduced already 50 compiler warnings, as I said, in one file, and you change that file, then certainly you have to solve these 50 as well. But solving these relative targets, so only the ones that you have introduced yourself, that is something everybody agrees. The engineer will agree and say, okay, I introduced these, I should solve them as well. Yes, and that's the reason why we say for violation-like metrics, please use relative file-based targets. Also make sure that you don't set it for all violation-like metrics. So for instance, if we are talking about compiler warnings, don't say we don't allow any new compiler warnings anymore. Let's start with the most important one. So let's say something like, we do not accept new compiler warnings of severity level 1, 2, and 3, for instance. And the good thing here is you can start right away. We just say we baseline the history, what is already there, no problem. We didn't know in the past, but now we are starting with quality targets. From now on, we don't accept anything new anymore. And the funny thing is that what we see in companies is that everybody accepts this. So even project managers who are very keen on time to market and putting pressure on your project, etc., they will say it's okay. So I accept if you accept the current situation, but we are not going down. We are not allowed to degrade in quality with respect to these violation-like metrics. Fine. So the consequence is that your quality will go up with this. So every commit, every delivery, people will make very small steps towards a better quality. But the downside here is that it will take some time because, yeah, of course, the ones that are already in will not be solved unless, of course, you refactor a lot and then they are probably gone. If you remove some code or files, then they are gone too. So that's the thing to get away with it. But there's one more thing that people don't realize. So suppose you have a new file, completely new file, and then of course, yeah, what was the previous situation? You had 0 violations, so, and 0 compiler warnings. So if you have a new file, you are not allowed to introduce any new one. So it start at 0 and it will remain 0. Okay, now the second golden rule is the following, and that is that if you have threshold-like metrics, then you should do something different. So let's say we are talking about a very popular one, cyclomatic complexity. So that's about the complexity of your code. And actually what it does, it counts the number of paths through a function. So if you have a function with a lot of if statements and else and whiles and etc., you have a lot of paths through your code. So let's say you have a function with 20 paths through it. Then, okay, so suppose you have to fix a bug. You have to touch that function with 20 cyclomatic complexity paths, and you have to add one if statement because you forgot it, and that's why you had this bug. You add this if statement, and then suddenly the complexity goes from 20 to 21. Yeah, and if you had a relative target here, file-based, then you were not allowed to deliver this fix. Yeah, because you increase the cyclomatic complexity, which is of course a bit ridiculous. So you have to be very careful that not all the metrics can be used to set them in a relative way and for file-based. So that's why we say these ones you set as at project scope. So if somebody adds an if statement, yeah, okay, there's no problem. If the overall system meets a certain threshold, then it's okay. So if we say the overall system on average may have, let's say, 20, then of course there will be some functions that have 25, some have 2, and well, that doesn't matter. If the overall feeling is okay, then it's okay. And this is also a kind of way of saying, well, we shouldn't check them every time, every delivery. Now it's better to check them a couple of times during your sprint, and you can put it in the definition of done that you say, well, the overall cyclomatic complexity will not exceed a certain threshold at the end of the sprint. And there's somebody who should take care of that and monitor this and also tell people, hey, watch out, we are getting close to our threshold, and if it goes beyond that, we have to take action. And last but not least, yeah, of course, suppose you will go, the absolute target is set to something and you go below that, then of course you shouldn't blame the one who is the last one who checked in something. No, you have to look at it as a team and see where are the big violators of this threshold and how to solve this. Usually it also is more, let's say, architectural thingy that has to be done, and that is something where more people are involved than just one individual engineer. So these are actually the 2 golden rules for quality targets. And once again, you can only do this if you have done all the stuff that I have defined before you can start doing this. And of course, also if you have defined all this, you're still not there. There is one thing missing, and that is that you should use your quality targets to set quality gates. Because if you don't set quality gates, then nothing will happen actually. So you really need to have them. And how do they look like? Well, actually you can set quality gates all over your system. So you can say people are not allowed to check in their code, or during our integration merge, we are going to do some things, or even it could be done, you can have a quality gate prior to release. So just as a pre-release, even after release, you can have some quality gates. That's also possible if you, before you actually deliver an update or something like that. It could be a trigger for being forced to deliver an update of your software. So there are all phases in your system where you can put these. And there's also something I would like to advise or recommend to you, is what we see is that if you have a metric that can be calculated during development and it can be done very fast, then please put it as close to the engineer as possible. So suppose we are talking about coding standard violations. Well, most of them you can check as you type. So in your integration environment or your programming environment like Eclipse or Visual Studio or so, you can already, for some languages, you can already warn people as they type. So you can already say, hey, you are now doing something you are not allowed to deliver. So that's already very fast. You can also do it by just running a tool client-side within your programming environment. But the slow metrics, and there are slow metrics, I can give you an example in a second, but slow metrics you shouldn't run on the client side, because you don't want to block the engineer from making progress by running something that takes 3 hours every time the engineer wants to commit something. So that's something you have to do during your nightly build or something like that, and then you can actually trigger that. So if you're talking about slow metrics, for instance, one of them is code coverage usually. So if you have a lot of unit tests to run and it takes 3 hours to run all your unit tests, then of course you cannot put that at the client-side machine, because the client, well, this engineer doesn't want to wait for 3 hours. So that's something that's typically done at the server side. And there you can set targets as well. I've got an example here. This is our dashboard. You see at the left-hand side some projects. I've selected one project, and that project has a C score, as you can see. And you see also a red flag at the left-hand side. So there's something going wrong. So the quality gate was not passed. And apparently there are 2 quality things measured. One is that is a project-based absolute target, that the unit test coverage should be at least 50%. It's only 44.7, so something needs to be repaired there. But the other one, that is about a delta of coding standard violations of level 1 to 6, that is respected. So yeah. So that is okay. So that one is green, but the one about unit test coverage is red. So yeah, that quality target is not met. So, well, we are at 45 minutes of my presentation. This is also my last slide. So what we did, in summary, we looked at quality targets first by looking at what is all needed to be able to set realistic targets. I forget to say one more thing. If you measure all this with metric tools and with code checkers, then you get also a feeling about what are realistic targets. So suppose you have you say, well, we don't accept any compiler warnings of level 1, and you have, let's say, 100,000 in your system, then maybe that's not a good target. So you first have to look at the data that you've got and then make a decision based on that. So we looked at this whole list, and if you have this all available, then and you apply the golden rules and you make sure that you also have quality gates in place, then you can start improving. Okay, that's it for now. So let's have a look whether we have some questions. Let me see how this works. Where is my... Yeah, okay. So now I have to look at the chat. Yeah, so there was one question. I see that is... any metrics used for software testing to verify the quality of software? Yeah, I already talked about that. That's what we use, and that is the code coverage. So we don't not only look at code coverage of unit tests, but also at code coverage of integration tests. So some people have, for instance, user interfaces where they use Selenium tests. We can also measure code coverage of the Selenium tests. You have system tests that you can also code cover. But apart from that, there are other metrics that also have to do with testing. For instance, you can also take the number of succeeded tests. So if, let's say, you have 100 tests and 2 fail, then you have 98% of tests succeeded. That's another software metric that you can use. We don't use that one because yeah, we don't have a good feeling about how to qualify this. What does that mean if 2 out of 100 don't succeed? Then if these 100 tests are doing silly things, well, what does it say? So that's a problem. Yeah, hopefully does that answer your question. There's another question from Raja. How accurate are these metrics to qualify as clean code? Yeah, that's also a good point. So we have this clean code philosophy available. One of the things in clean code is that an important one is that you use the Boy Scout rule, and that if you have your code and you would make a change, then you should leave it behind as clean as it was before. That's actually a redefinition of a relative target. So what you're saying, you are not supposed to introduce new things. So you don't make new waste. If you look at the specific clean code metrics, well, some of them are in our system, but we are not talking about our system, but you can put them into your system. So there are code smells defined in clean code. So please put them in, check whether they fulfill the criteria of being a good software metric. Try to make a qualification for it, so what's good, what is bad, and then try to find tools that can check that for you. Okay, so there's another question. Does warning effects on the performance of the software also, or it's for code optimization only? Yeah, so if I interpret this question correctly, it says, well, if we have a compiler warning, does it have to do something with performance? Or maybe is there a coding standard violation that can help you with performance? Yes, there certainly is. So if you're talking about compiler, so compilers have performance compiler warnings. So you can take these into account, and these count also for your overall quality. Performance is also one of the characteristics of this ISO 25010, so that's something you have to take into account. Moreover, there are lots of coding standard rules that are about performance, like things that you shouldn't do, like for instance, you are declaring a variable in an inner loop, and that variable doesn't change, and you are, for instance, initializing it every time, or creating that object every time, whereas it only needs to be created once, so it shouldn't be part of this inner loop. So there are all kinds of checks there. On the other hand, performance in general is something that's very hard to measure, at least in an objective way. So if, let's say, you have a project where a millisecond is okay, and in another project a millisecond is not okay, because it's a real-time system. So it really depends on context whether some performance is okay or not. So that's, from a general point of view, performance is very hard to make objective. So to make objective metrics for them. Okay, are there any other questions? Did this help you a little bit? Does this answer a question for you? Thank you, Raja. So yeah, I got a response from Raja, so I see that these comments are all in private, so you can't see them. He was very pleased. He or she, I'm very bad in knowing whether Indian names are from men or women. Well, you probably have the same with European names. Okay, there is another question from Aniruja. While dealing with a legacy product that is matured and under sustenance, which has an existing procedure of logging customer complaints and addressing them, what do you think is a better way to improve quality, product quality? Yeah, so legacy systems, how do you improve the quality of legacy systems? That's in short the question that is asked. A very good question, by the way, because most of the systems don't start from scratch. There's already a lot of releases done, and then people start complaining about quality, and then they say we have to improve. Then I think it's really, really important to convince management of the system that you cannot improve it very quickly. So you have to do that step by step, and there I would really focus on the relative targets. So make sure that you are set these relative targets. So you can say from now on we measure quality as a baseline. That's it. Probably is quite bad, but from now on every change will be better than the system itself. So with every small change and every bug that you solve, you also solve all the indicators, and you can show that to your customers. And this is something customers really like. If you show them every change I'm going to make for you, we leave the system better than it was before. So please go for relative targets, because if you go for absolute targets and say, well, we are going to solve all the compiler warnings that are in, you get crazy. And moreover, this system is already existing for a long period, and it has been working in the field for a long time, and maybe it has bugs, but please don't touch them unless you really need to. So don't make improvements in code that you won't change. That's my recommendation here. Okay, so I think we are through all the questions and answers. Of course, you can contact Meteonic if you want to have more information about this, that we really appreciate that. And of course, you can also reach me via the email addresses. One more question from Raja. Okay, what languages does your product support? Actually, you can see that on this page or fact sheet. So if you go to the top, you see that we support about 20 different languages. It's a kind of framework where you can plug in all kind of code checkers. Yeah, if there is also a language that we don't support, then it's a framework, so we can easily add a new language if needed. Okay, thanks everybody, and I wish you a very pleasant evening, and I hope to see you in India soon when I'm allowed to come over to Bangalore or whatever other city in India again. So Ankur, you want to say something?
Yeah, thank you, Paul. I think it was really interesting and useful. We will be in touch with all the participants. If they have any question offline also, I will get back to you. Guys, you guys want to try it, even single try will tell you where you are currently at the quality matrix, and will definitely help you how you can move it. And many companies across the globe are using Tics, our product, and making a really difference in the product quality. So we look forward hearing from you about feedback, and if you want to try our product. Thank you so much for this call. Thank you, Paul. Thank you so much.
Yeah, thank you everybody. Bye bye.
Bye bye. Take care. Bye. Bye, Paul.
Thank you, Paul.